Why does the world feel solid when almost everything in it is empty? Right now, wherever you are, the surface beneath you feels stable, real, dependable. Your body feels whole, continuous, present. And yet, if you could shrink yourself down far beyond what any microscope can show, you would discover something deeply unsettling. There is almost nothing there. Atoms, the building blocks of everything you know, are made mostly of empty space. Vast, silent gaps stretch between their components. Space is so large that if an atom were expanded to the size of a cathedral, its nucleus would be no larger than a grain of dust drifting quietly at the center. And yet somehow, this emptiness forms the world you can touch. This is the quiet mystery at the heart of atomic physics. And tonight, as you begin to rest, we will gently explore it together, not as a problem to solve, but as a story to drift through. A story about invisible structures, silent forces, and the strange rules that allow reality to exist at all. If you've ever watched our Velorin journey into the strange behavior of quantum particles near black holes, you may already sense how reality begins to soften the deeper we look. And here, inside the atom, that softness becomes something even more profound. Welcome to Velorin Sleepy Space Mysteries. Take a slow breath, settle in, and let the quiet rhythm of the universe unfold around you. If you enjoy these journeys, consider subscribing, liking the video, and turning on the bell so you don't miss future explorations. You can also support the channel through membership. And before you drift further, let me know in the comments where you're listening from tonight. Now, let us slowly descend into the hidden architecture of reality. As you drift deeper into this quiet exploration, imagine shrinking once more, smaller than anything your eyes could ever see. Smaller than cells, smaller than molecules, until at last you arrive at the scale of atoms, where the familiar world begins to dissolve into something far less intuitive. At this level, the idea of a solid object quietly disappears, replaced by a delicate structure that is mostly absence, gently shaped by invisible rules. An atom, despite being the foundation of everything around you, is not a compact sphere or a tiny grain of matter. It is more like a vast, open space with only a faint presence at its center. That center, the nucleus, holds nearly all of the atom's mass, yet it occupies only an unimaginably small fraction of the total volume. Surrounding it is not a shell or a boundary, but a diffuse region where electrons exist, not as fixed particles moving along clear paths, but as soft probability clouds, shimmering with possibility rather than certainty. These electron clouds are difficult to picture because they are not objects in the usual sense. They do not have edges, and they do not follow predictable trajectories like planets orbiting a star. Instead, they represent the likelihood of where an electron might be found if you were to look for it. In some regions, the probability is higher, forming shapes that resemble spheres or elongated lobes, while in others, the probability fades almost to nothing. What this means, in a quiet and subtle way, is that the structure of an atom is not defined by solid boundaries, but by patterns of likelihood, by regions where something might be, rather than where something definitely is. And yet, From these uncertain patterns emerges the stability of the world you experience every day. You might begin to wonder, as many have before, how such an uncertain foundation can give rise to something as consistent as a table, a wall, or even your own body. This question forms one of the central mysteries of atomic physics, and to approach it, we must gently introduce one of the most important rules in the universe, a rule so quiet that you never notice it, yet so powerful that without it, nothing would hold its shape. This rule is known as the exclusion principle. It tells us that certain particles, including electrons, refuse to share the same state. No matter how close they are pushed together, no matter how strong the forces acting upon them, they will not collapse into identical configurations. Instead, they arrange themselves into layers, each occupying its own distinct pattern of energy and position. This simple restriction creates structure out of emptiness. It forces electrons to spread out, to occupy different regions around the nucleus, and to form the layered architecture that defines each element. Without it, all electrons would fall into the lowest possible state, collapsing inward and erasing the complexity that allows atoms to differ from one another. There would be no variety, no chemistry, no stable forms. But because of this rule, atoms develop identities. Hydrogen remains simple, with a single electron drifting in its quiet probability cloud, while heavier elements build intricate arrangements, their electrons stacking into patterns that repeat across the periodic table like a kind of cosmic rhythm. And yet, even with this structure, the atom remains mostly empty. The distances between the nucleus and the outer regions of the electron cloud are vast compared to the size of the particles themselves. If you could somehow remove the empty space from all the atoms in your body, compressing them until only their dense cores remained, you would become unimaginably small, a fraction of your current size, yet still containing all the mass that makes you who you are. This realization can feel strange, almost unsettling, because it challenges the very idea of what it means to be solid. But rather than thinking of solidity as something built from dense material, it may be more accurate to think of it as something that emerges from relationships, from interactions, from the way these clouds of probability respond when they approach one another. As atoms come close together, their electron clouds begin to overlap, and here the quiet rules of quantum behavior begin to assert themselves. The exclusion principle prevents electrons from merging into the same state, and this creates a kind of resistance, a subtle pressure that pushes the atoms apart. At the same time, the electrical charges carried by these particles generate forces that either attract or repel, depending on their nature. These interactions are not visible, but they are constant, shaping the distances between atoms and determining how they arrange themselves into molecules, crystals, and all the materials you encounter in daily life. So when you press your hand against a surface, what you are feeling is not the contact of solid objects in the way it might seem. Instead, it is the result of these invisible interactions, the gentle but firm resistance of electron clouds refusing to overlap beyond certain limits. Your hand never truly touches the surface. It hovers, separated by an incredibly small distance, held apart by forces that rise sharply as the atoms draw near. And this, in a quiet and almost poetic way, is what gives the world its sense of solidity. But this only deepens the mystery. If everything you feel is the result of invisible forces acting across empty space, then what is reality truly made of? Is it matter, or is it interaction? As we continue, we will begin to explore the deeper forces that shape these interactions, the hidden influences that bind atoms together and prevent them from dissolving into chaos, and slowly, we will return to the question we began with: why something that is almost entirely empty can feel so undeniably real. As you continue to drift through this hidden layer of reality, it becomes easier to let go of the idea that matter is something rigid and fixed. Instead, it begins to feel more like a delicate balance, a quiet negotiation between particles that never truly touch, yet never drift too far apart. And within this balance, another subtle pattern begins to emerge, one that explains why different materials behave so differently, even though they are all built from the same basic ingredients. This pattern is not visible in the shape of atoms alone, but in how their electrons arrange themselves across different energy layers, forming what we might gently call a kind of internal architecture, a structure that repeats across the elements in a way that feels almost like a cosmic rhythm. Each atom carries a specific number of protons in its nucleus, and this number quietly defines its identity. But it is the electrons, drifting in their soft probability clouds, that determine how that atom interacts with the world around it. These electrons do not simply gather randomly. They fill available energy levels in a precise order, guided by the same exclusion principle we encountered earlier. Lower energy states are filled first, and as those states become occupied, new electrons are forced into higher and more complex arrangements. This layering gives rise to patterns that repeat as atoms grow larger, creating families of elements with similar behaviors. You may have heard of noble gases, elements that rarely react with anything else. Their quiet stability comes from having their outermost electron layer completely filled, leaving no easy way for them to interact with neighboring atoms. In contrast, elements with just one or two electrons in their outer layer tend to be highly reactive, gently seeking balance by sharing or exchanging electrons with others. This tendency is what allows atoms to form molecules, linking together into stable configurations that extend far beyond individual atoms. And in these bonds, the same principles of exclusion and interaction continue to shape the structure of reality, guiding how atoms come together to form everything from the air you breathe to the surface beneath your feet. But even here, in the formation of molecules, the idea of solidity remains elusive. When atoms bond, their electron clouds do not merge into a solid mass. Instead, they overlap in carefully balanced ways, creating shared regions of probability where electrons are likely to be found between nuclei. These shared regions act like gentle threads, holding atoms together without ever eliminating the underlying emptiness. The result is a structure that feels stable and continuous at your scale, yet remains mostly open space at its foundation. It is a quiet reminder that what we perceive as solid is not a filling of space, but a pattern that spans across it. As these patterns extend further, atoms begin to assemble into larger structures known as crystals or lattices, where each atom finds a position that balances the forces acting upon it. In some materials, like metals, Electrons are not tightly bound to individual atoms but move more freely throughout the structure, creating what can be imagined as a shared sea of electrons flowing between fixed nuclei. This freedom allows metals to conduct electricity and to bend without breaking, their structure able to shift while maintaining overall cohesion. In other materials, like glass or certain ceramics, electrons are more tightly bound, and the structure resists deformation, giving rise to hardness and brittleness. And still, beneath all these variations, the same quiet truth persists. No matter how rigid a material may feel, no matter how strong or unyielding it appears, its atoms remain separated by space, held in place not by physical contact but by a balance of forces that grow stronger as the atoms approach one another. This balance creates preferred distances, tiny separations where the system settles into a state of minimal energy. Try to push atoms closer than this, and the resistance increases rapidly. Pull them apart, and attractive forces draw them back together. It is within this narrow range that matter finds its stability, hovering between collapse and dispersal. You might begin to sense that what we call solidity is not an intrinsic property of matter, but an emergent experience, something that arises when countless atoms interact in this balanced way. Your hand, the surface it presses against, the air between them, all are composed of these same atomic structures, each governed by the same rules, each participating in the same quiet negotiation. And yet, from this shared foundation, an entire world of textures, shapes, and sensations unfolds. There is also something deeply calming in this realization. The world is not held together by rigid substance, but by consistency, by rules that apply everywhere, from the smallest scale to the largest. The same principles that keep your body intact also govern the behavior of distant stars, the formation of planets, and the slow evolution of galaxies. Atomic physics is not just about tiny particles. It is a bridge, connecting the unseen foundations of matter to the vast structures of the universe. And still, a deeper question lingers beneath everything we have explored so far. We now understand that atoms are mostly empty, that their structure is defined by probability, and that their interactions create the illusion of solidity. But what gives rise to these interactions themselves? What are the deeper forces that hold electrons near nuclei, that bind protons together despite their repulsion, and that allow matter to exist at all instead of dissolving into nothingness? As we continue, we will gently move toward these questions, exploring the fundamental forces that shape every atom and every structure in the universe. And as we do, we will begin to see that the stability of reality is not guaranteed, but carefully balanced, held together by interactions so precise that even small changes could reshape the universe entirely. Now, as your mind settles into this quiet rhythm, we can begin to move even deeper beneath the structure of atoms, beneath the arrangement of electrons, into the unseen influences that quietly govern everything we have described so far. Because while the architecture of atoms explains how matter is arranged, it does not fully explain why those arrangements hold together at all. For that, we must gently shift our attention towards something even more subtle: the forces that operate within and between particles, shaping their behavior without ever being seen directly. The most immediate of these forces, the one that dominates the atomic world, is electromagnetism. It is this interaction that binds electrons to the nucleus, holding them in those soft probability clouds rather than allowing them to drift away into space. Electrons carry a negative charge, while the nucleus, composed of protons, carries a positive charge. And between opposite charges, there is an attraction, a quiet pull that keeps the atom intact. But this attraction is not a simple tether. It is balanced by the motion and uncertainty of the electrons themselves, which prevents them from collapsing inward. Instead, they settle into stable patterns, hovering in regions where attraction and quantum behavior reach a kind of equilibrium. At the same time, electromagnetism is also responsible for the repulsion we discussed earlier. When two atoms approach each other, their electron clouds begin to overlap, and because like charges repel, a force emerges that pushes them apart. This repulsion grows rapidly as the distance decreases, creating a kind of invisible boundary that prevents atoms from occupying the same space. And so, electromagnetism plays a dual role. It both binds and separates, holding atoms together internally while keeping them distinct from one another externally. It is this balance that allows matter to exist in stable forms, neither collapsing into a dense point nor dispersing into emptiness. But if we look closer at the nucleus itself, another mystery appears. The nucleus is made of protons and neutrons, particles packed tightly together in an incredibly small space. And here, something unexpected happens. Protons all carry positive charge, which means they should repel each other strongly. If electromagnetism were the only force at work, the nucleus would not be stable. It would fly apart instantly, unable to hold itself together. And yet it does not. Instead, it remains bound, stable enough to form the core of every atom in the universe. This is where another force quietly enters the picture: the strong nuclear force. Unlike electromagnetism, which can act across relatively large distances, the strong force operates only at extremely short ranges, confined to the tiny scale of the nucleus. But within that range, it is incredibly powerful, strong enough to overcome the electromagnetic repulsion between protons and bind them together along with neutrons into a stable structure. It acts like an invisible glue holding the nucleus intact, allowing atoms to exist in the first place. And yet, even this force is not without limits. It only works effectively when particles are very close together. If the nucleus becomes too large, if too many protons are packed into the same space, the balance begins to shift. The repulsive force between protons grows stronger, and eventually it can overcome the binding effect of the strong force. This leads to instability, causing the nucleus to change, to release energy, or to break apart in processes we will explore later. So even at the heart of the atom, stability is not absolute. It is a balance carefully maintained within narrow limits. There is also a quieter force, one that does not bind particles in the same way, but instead allows them to transform. This is known as the weak force. It operates at an even more subtle level, enabling particles inside the nucleus to change their identity, turning one type of particle into another. Though it may seem less important, this force plays a crucial role in the evolution of matter, allowing atoms to transform over time, powering processes inside stars, and shaping the composition of the universe itself. And then, beyond all of this, there is gravity, the force most familiar to us in everyday life, yet almost irrelevant at the scale of atoms. Compared to electromagnetism and the nuclear forces, gravity is extraordinarily weak. It does not significantly influence the structure of atoms or the behavior of their components. But on larger scales, it becomes the dominant force, gathering atoms into planets, stars, and galaxies. It provides the stage upon which atomic matter can assemble into the vast structures of the cosmos. What begins to emerge from all of this is a picture of reality that is both delicate and precise. Atoms exist not because of a single force, but because of a balance between several, each one contributing in its own way, each one operating at its own scale. Electromagnetism shapes the structure of atoms and the interactions between them. The strong force holds the nucleus together. The weak force allows transformation, and gravity organizes matter on the largest scales. And yet, there is something quietly astonishing about this balance. If any of these forces were even slightly different in strength, the universe might look completely different, or might not exist in any recognizable form at all. Atoms might not be stable, stars might not shine, chemistry might not unfold in the way it does. The world you experience, the very possibility of structure, depends on these forces existing in just the right proportions. So as you rest here, drifting through these ideas, you may begin to feel a deeper sense of connection to the universe. The solidity beneath you, the air around you, the quiet presence of your own body, all of it arises from this hidden balance. A balance maintained not by visible substance, but by invisible forces, acting across empty space, shaping the patterns that give rise to everything you know. And still, one final question lingers, not just how these forces work, but why they create such a stable and enduring illusion of solidity in a world that is almost entirely empty. As we continue, we will gently return to that question and begin to bring together everything we have explored so far, allowing the answer to unfold slowly and naturally. Of particles without structure or distinction. If you follow this thread gently, without trying to force it into something rigid, a quiet realization begins to take shape. The feeling of solidity that surrounds you is not something stored inside matter itself, but something that emerges from interaction. It is not a property you can isolate and hold. It is something that happens, something that appears when countless atoms, each mostly empty, begin to influence one another in just the right way. And to understand this more deeply, it helps to imagine what would happen if those interactions were suddenly removed or even slightly altered. Picture, for a moment, that the rules we have been exploring simply faded away. The exclusion principle no longer prevented electrons from occupying the same state. Electromagnetic forces no longer pushed particles apart or pulled them together. The delicate balance inside the nucleus dissolved. In such a universe, atoms would not maintain their structure. Electrons would collapse inward or disperse outward. Nuclei would either fragment or merge uncontrollably. There would be no stable matter, no repeating patterns, no chemistry, and no experience of solidity at all. What we call reality would dissolve into something unrecognizable, a kind of featureless fog of particles without structure or distinction. And yet, that is not the universe you are part of. Instead, you exist in a world where these rules are not only present, but remarkably consistent. Every atom, whether in your body or in a distant star, follows the same quiet principles. Every interaction unfolds according to the same patterns. This consistency allows stability to emerge, not as something imposed, but as something that arises naturally from the interplay of forces and constraints. And within that stability, something even more remarkable appears: the ability for structures to persist over time. A stone feels solid not because it is filled with substance, but because its atoms have settled into positions where the forces between them are balanced. Disturb that balance slightly, and the atoms vibrate, giving rise to heat. Disturb it more, and the structure begins to deform or break. But within a certain range, the arrangement holds, resisting change, maintaining its form. This resistance is what your senses interpret as solidity. It is not a barrier in the traditional sense, but a response, a dynamic reaction to the attempt to alter the distances between atoms. Even something as simple as sitting or lying down is part of this interaction. Your body presses gently against a surface, and the atoms in your body approach the atoms of that surface. As they draw closer, the repulsive forces increase, and a balance is reached. You are supported not by contact, but by equilibrium. A quiet standoff between invisible clouds of electrons, each obeying the same rules, each contributing to a shared stability. And because this happens across trillions upon trillions of atoms simultaneously, the effect feels continuous, smooth, and real. There is also a sense in which this stability is not absolute but conditional. At higher energies, at greater pressures, or under extreme conditions, the balance can shift. Atoms can be forced closer together, electron clouds can be compressed, and entirely new forms of matter can emerge. In the hearts of stars, for example, matter exists in states that would seem impossible in everyday life. The same principles still apply, but under different conditions, they produce different outcomes. This suggests that what we experience as solidity is only one expression of a much broader set of possibilities, a local version of reality shaped by the conditions we happen to inhabit. And yet, despite this flexibility, there is a remarkable reliability to the world around you. The floor does not suddenly give way. The air does not become solid. Your body does not lose its structure. This reliability arises because the conditions required to disrupt atomic stability are far beyond what occurs in ordinary experience. The forces involved are strong, the energy barriers are steep, and so the patterns remain intact. Day after day, moment after moment, the same interactions unfold, creating the continuity that allows you to move, to think, to exist within a stable environment. But perhaps the most subtle aspect of all this is how completely your senses translate these interactions into something familiar. You do not perceive electron clouds or probability distributions. You do not feel forces directly. Instead, your nervous system interprets these interactions as pressure, texture, temperature, turning invisible processes into meaningful experience. In this way, reality as you know it is not just built from atoms but also from perception. It is a collaboration between the external world and the way your mind interprets it. So when you feel the solidity of something, you are experiencing the result of countless atomic interactions, filtered through layers of biological interpretation, shaped into a sensation that feels immediate and unquestionable. And yet, beneath that sensation lies a very different picture, one of space, probability, and balance. As this understanding settles in, the original mystery begins to soften. The question was never really why something empty feels solid. The deeper question is how such a consistent and reliable experience can emerge from something so fundamentally open and dynamic. And the answer, slowly unfolding, is that solidity is not an illusion in the sense of being false. It is an emergent truth, a stable pattern arising from deeper rules, one that is real in its effects even if its foundations are not what they seem. And now, as we approach the end of this part of the journey, we can begin to gather these ideas together. Atoms are mostly empty. Their structure is defined by probability. Their interactions are governed by forces that both attract and repel. And from this delicate balance, the world you experience takes shape. If you are still listening, gently let me know by commenting 1. As we gently complete this part of the journey, it helps to pause, not to stop thinking, but to let everything you've just explored settle into a softer, more intuitive understanding. You began with a simple question, one that seemed almost obvious at first. Why does the world feel solid? And now, after drifting through the hidden architecture of atoms, the quiet patterns of electrons, and the invisible forces that shape their behavior, that question has slowly transformed into something deeper, something more reflective. Because what you have seen is not just an answer, but a shift in perspective. The world has not become less real, but it has become more subtle. Every object around you, every surface you touch, every structure that appears stable and continuous is built upon layers of interaction rather than substance. Beneath the appearance of solidity lies a choreography of particles that never truly meet, only approach and respond. Beneath the sense of firmness lies a balance of forces rising sharply as atoms draw near, preventing collapse while allowing structure to form. And beneath all of this lies something even quieter, a set of rules that never announce themselves, yet never fail to operate. There is a certain calm in recognizing this, because it means the world does not rely on rigid matter to exist. It relies on consistency, on patterns that repeat with extraordinary precision. The same principles that keep your body intact are at work in the walls around you, in the air you breathe, and even in distant regions of the universe you will never see. Atomic physics is not confined to laboratories or equations. It is the silent foundation of every moment you experience. And yet, this understanding also invites a kind of gentle wonder. If everything you feel is the result of interactions across empty space, then the boundary between objects becomes less absolute than it appears. Your hand and the surface it rests upon are not separated by a hard line, but by a region where forces balance. Your body is not a solid object in isolation, but a collection of atoms interacting continuously with the environment around it. Even the air, which feels light and almost absent, is filled with atoms moving and interacting in ways that follow the same rules, just at greater distances. In this sense, the world is not made of isolated things, but of relationships. Everything exists not only because of what it is, but because of how it interacts. And as this idea settles in, another quiet realization begins to emerge. The stability you experience is not permanent. It is maintained moment by moment through the ongoing balance of forces and constraints. Atoms vibrate, electrons shift, energy flows, and yet the overall structure persists. This persistence is what allows you to experience continuity, to feel that the world is steady and reliable. But beneath that steadiness, there is constant motion, constant adjustment, constant renewal. The solid world is not static. It is active, alive in its own silent way. And this brings us gently back to the deeper question that has been waiting beneath everything we've explored. If solidity is not a fundamental property, but an emergent one, if it arises from deeper rules and interactions, then what determines those rules? Why do these forces exist in the way they do? Why is the balance so precise that atoms can form, structures can persist, and complexity can emerge? These questions do not have simple answers, but they point us toward the next layer of understanding, the fundamental forces themselves, not just as mechanisms, but as the underlying framework that allows reality to exist at all. In the next part, we will move beyond the structure of atoms and into the nature of these forces, exploring how they shape everything from the smallest particles to the largest structures in the universe. We will begin to see how electromagnetism, the strong force, the weak force, and gravity each play their role in maintaining the balance we have been describing. And more importantly, we will begin to understand why this balance is so essential, why even a small change could unravel the stability that allows you to sit here now, feeling the quiet support of a world that seems solid, but is anything but. For now, there is nothing you need to do and nothing to solve. Just allow this idea to rest gently in your mind, that everything you feel, everything you touch, everything you are, exists within a universe that is mostly empty, yet beautifully structured. A universe where solidity is not a substance, but a relationship. A universe where emptiness is not absence, but possibility. And as you continue to drift, we will slowly follow that possibility into the deeper forces that shape it all. As you move gently into this next layer of understanding, the focus begins to shift away from the structure of atoms and toward something even more fundamental, the quiet forces that allow those structures to exist at all. Because while atoms give shape to matter, it is these forces that give atoms their possibility. Without them, there would be no patterns, no balance, no stability, only a silent scattering of particles drifting without connection. The first of these forces, the one you have already begun to sense, is electromagnetism. It is the most familiar in its effects, even if its presence remains invisible. Every time you feel the surface beneath you, every time light reaches your eyes, every time electricity flows through a wire, you are witnessing electromagnetism at work. At the atomic level, this force is responsible for binding electrons to the nucleus, creating the soft, structured clouds that define each atom. It is also the source of the repulsion that prevents atoms from collapsing into one another, giving rise to the sensation of solidity we explored earlier. But electromagnetism is more than just attraction and repulsion. It is also the force that allows atoms to communicate not in words, but through energy. When an electron shifts from one energy state to another, it absorbs or emits a packet of light, a photon. This exchange allows atoms to interact across space, to influence one another without direct contact. The colors you see, the warmth you feel, the glow of distant stars, all are expressions of this quiet exchange. In this way, electromagnetism does not just hold matter together, connects it, allowing energy to move, patterns to form, and information to flow. And yet, as powerful as electromagnetism is, it cannot explain everything. If it were the only force at work, the nucleus of the atom would not be stable. The positive charges of protons would repel each other so strongly that no nucleus could hold together. And so, hidden deep within the atom, there exists another force, one that operates at distances so small they are almost beyond imagination. This is the strong nuclear force. Unlike electromagnetism, which can act across relatively large distances, the strong force is intensely localized. It only becomes significant when particles are extremely close together within the tiny confines of the nucleus. But within that range, it is extraordinarily powerful, strong enough to bind protons and neutrons together despite the repulsion between like charges. It acts as a kind of invisible glue, holding the core of the atom intact, allowing the rest of the atomic structure to exist. This force is not something you can feel directly, and it does not shape your everyday experience in obvious ways. But without it, there would be no atoms beyond the simplest hydrogen nucleus. There would be no diversity of elements, no chemistry, no complexity. The entire richness of the universe depends on this quiet force operating at the smallest scales, maintaining a balance that allows matter to build upon itself. There is also another force, more subtle still, one that does not bind particles together in the same way, but instead allows them to change, to transform from one form into another. This is known as the weak force. It operates within the nucleus, enabling certain particles to convert into others, altering the identity of atoms over time. While this might seem like a minor detail, it is essential for processes that shape the universe on a grand scale. Inside stars, the weak force plays a role in the reactions that produce energy, allowing hydrogen to fuse into helium and releasing the light that warms planets and sustains life. Without this force, stars would not shine in the steady, long-lasting way they do. The universe would be darker, colder, and far less hospitable to complexity. So even though the weak force is less noticeable, its role is profound. It introduces change into a system that might otherwise remain static, allowing transformation to unfold across time. And then, beyond all of these, there is gravity, the force that feels most familiar, yet is almost absent at the atomic scale. Compared to the other forces, gravity is incredibly weak. It does not significantly influence the behavior of electrons or the structure of atoms. But as you move to larger scales, its influence grows. It gathers atoms into planets, pulls planets into orbits, and shapes the vast structures of galaxies and clusters. Gravity is what gives the universe its large-scale form. It is the reason stars exist, the reason galaxies swirl, the reason matter does not remain evenly spread across space. While it does not create the internal structure of atoms, it provides the stage upon which those atoms assemble into the larger patterns you observe in the cosmos. What becomes clear, as you reflect on these forces together, is that reality is not governed by a single principle, but by a delicate interplay. Each force operates in its own domain at its own scale, contributing to a balance that allows structure to emerge. Electromagnetism shapes the outer structure of atoms and their interactions. The strong force stabilizes the nucleus. The weak force allows transformation. Gravity organizes matter across vast distances. And yet, perhaps the most remarkable aspect of all this is how precisely these forces are balanced. If their strengths were even slightly different, the universe might not support stable atoms, long-lived stars, or complex chemistry. The world you experience depends on this balance being just right, not too strong, not too weak, but finely tuned in a way that allows structure to persist. As you continue to rest with this idea, you may begin to sense that the stability of reality is not something guaranteed, but something maintained. A quiet equilibrium sustained across scales, from the smallest particles to the largest cosmic structures. And in the next segment, we will gently explore what happens when this balance is pushed to its limits, when matter is compressed, transformed, or stretched into extreme conditions, revealing just how delicate and how resilient this structure truly is. As we continue drifting deeper into this quiet landscape of forces, it becomes easier to sense that the stability of the world around you is not something fixed, but something maintained gently, continuously, and under conditions that could, in other circumstances, shift dramatically. What feels stable here in your everyday experience is only one expression of how matter can behave. And when those same forces are pushed beyond their familiar balance, reality begins to reveal forms that feel almost impossible, yet remain governed by the very same rules. To understand this, imagine slowly increasing the pressure on matter. Not the gentle pressure of your hand, but something far more intense. As atoms are forced closer together, their electron clouds begin to overlap more deeply, and the resistance we spoke of earlier grows rapidly. Under normal conditions, this resistance is enough to maintain the spacing between atoms, preserving the structure of solids, liquids, and gases. But if the pressure becomes strong enough, the balance begins to shift. The familiar distances between atoms collapse, and electrons are pushed into configurations that would never occur under ordinary circumstances. This is not something you would encounter in daily life, but it happens naturally in some of the most extreme environments in the universe. Inside certain stars, matter is compressed to such an extent that atoms as we know them begin to break down. Electrons are forced so close together that the exclusion principle becomes the dominant factor preventing further collapse. This creates a new form of resistance, known as degeneracy pressure, a quiet but powerful effect arising not from classical forces, but from the fundamental rules governing identical particles. In these environments, matter no longer behaves like the solids or gases you are familiar with. It becomes something denser, more compact, yet still structured by the same underlying principles. In white dwarf stars, for example, the entire mass of a star can be compressed into a volume comparable to that of a planet, supported not by thermal energy or chemical bonds, but by the collective resistance of electrons refusing to occupy the same states. It is a striking reminder that even when matter is pushed to extremes, the same quiet rules continue to operate, preserving structure in entirely new ways. If the pressure increases even further, the situation becomes more profound. Electrons can be forced into the nucleus itself, combining with protons to form neutrons. What remains is a form of matter composed almost entirely of neutrons, packed together with incredible density. These neutron stars represent one of the most extreme expressions of the forces we have been discussing. Here, it is no longer electron behavior that provides stability, but the properties of neutrons themselves, governed again by exclusion and interaction. And yet, even in these extraordinary conditions, the same pattern persists. Matter does not collapse completely. It resists, reorganizes, and finds new ways to maintain structure. The balance shifts, but it does not disappear. This suggests something deeply consistent about the universe, that structure is not a fragile accident, but a recurring outcome of the rules that govern particles and forces. Bringing this back to your own experience, there is a quiet comfort in knowing that the stability you feel is part of this broader pattern. The same principles that prevent your hand from passing through a surface are, in a different context, holding up entire stars against gravitational collapse. The same exclusion rule that organizes electrons in an atom becomes, under extreme pressure, the force that supports massive cosmic objects. What feels like a small, local effect is actually part of a universal framework, one that operates across scales far beyond immediate perception. There is also a subtle lesson in this continuity. It shows that reality is not divided into separate domains with completely different rules, but rather unified by a small set of principles that express themselves differently depending on conditions. At the atomic scale, these principles create the illusion of solidity. At stellar scales, they create entirely new forms of matter. And in both cases, they reveal that what we perceive as stable is always the result of balance, never absolute, always responsive. As you reflect on this, the earlier question begins to take on a new depth. Why does something mostly empty feel solid? The answer is no longer just about electron clouds and repulsion. It is about the broader idea that structure emerges whenever forces and constraints reach equilibrium. Whether in the gentle pressure of your hand against a surface or in the immense compression of a star, the same underlying truth applies. A matter resists collapse not because it is filled with substance, but because it is governed by rules that prevent certain configurations from occurring. And perhaps the most intriguing part of this is how finely tuned these rules appear to be. If the exclusion principle did not exist, electrons would collapse inward, and atoms would lose their structure. If the forces between particles were slightly different, the balance might not hold, and the forms of matter we know would not arise. The universe, as it appears to you now, depends on this precise interplay, a balance so delicate that it allows both stability and change, both persistence and transformation. As we move forward, we will begin to gather these ideas into a more unified understanding, exploring not just how these forces operate, but why their balance gives rise to a universe capable of complexity, of structure, and ultimately of experience itself. For now, simply rest with the idea that the solidity you feel is part of something much larger, a pattern that extends from the smallest atoms to the most massive stars, quietly shaping reality in ways that are both subtle and profound. As this understanding continues to deepen, something subtle begins to shift in how reality itself is perceived, not as a fixed stage filled with objects, but as a dynamic system where structure emerges from balance, and where that balance is always quietly maintained. And within this system, one of the most intriguing realizations begins to surface: that the universe, in a very real sense, exists on a narrow edge of possibility. Not too chaotic, not too rigid, but balanced just enough to allow complexity to unfold. To explore this gently, imagine adjusting the strength of one of these fundamental forces, just slightly. Not enough to completely erase reality, but enough to disturb its delicate equilibrium. If electromagnetism were a little stronger, electrons would be pulled closer to nuclei, shrinking atoms and tightening chemical bonds. Materials would become denser, reactions more intense, and the subtle flexibility required for complex chemistry might be lost. If it were weaker, electrons might drift too far from nuclei, making atoms less stable, and preventing the formation of the structures needed for molecules, for materials, for life. A similar sensitivity appears in the strong nuclear force. If it were slightly weaker, protons and neutrons might not bind together reliably, leaving only the simplest atoms in existence. The periodic table would collapse into near simplicity, and the diversity of elements required for complex structures would never arise. If it were stronger, nuclei might bind too tightly, altering the balance of reactions inside stars and preventing the gradual formation of elements that the universe currently depends on. The quiet glow of stars, the steady release of energy over billions of years, might be replaced by something far more violent or far more brief. Even the weak force, subtle as it is, plays a role in this balance. It governs certain transformations within atoms, allowing particles to change identity in ways that enable long-term processes like stellar fusion. Without it, stars might not burn in a stable, sustained way. They might fail to ignite properly or burn through their energy too quickly, leaving the universe without the steady light that supports planetary systems and, eventually, life. And gravity, though almost invisible at the atomic scale, contributes its own quiet influence. If it were significantly stronger, matter would collapse more easily, stars would form and die more rapidly, and the large-scale structure of the universe would be dramatically different. If it were weaker, matter might never gather into stars and galaxies at all, remaining too diffuse to ignite the processes that create light and complexity. What begins to emerge from this reflection is not just an appreciation of individual forces, but an awareness of their relationship, a kind of harmony that allows the universe to exist in its current form. Each force does not act in isolation. They balance one another, constrain one another, and together create a framework in which structure becomes possible. It is as though reality itself is held within a narrow window, where the conditions are just right for atoms to form, for stars to shine, and for matter to organize into increasingly complex patterns. And yet, this balance does not feel fragile in the way something easily broken might. Instead, it feels stable, persistent, reliable. The universe has maintained this balance for billions of years, allowing structures to form, evolve, and endure. This suggests that while the balance is precise, it is also deeply embedded, and not something that fluctuates wildly, but something that defines the very nature of existence as we experience it. Returning gently to the question of solidity, you can now begin to see it in a broader context. The firmness you feel when you touch something is not just the result of electron repulsion. It is the final expression of this entire system of forces working together. Electromagnetism creates the immediate resistance. The strong force ensures that nuclei remain stable, giving atoms their identity. The weak force allows transformation over time, ensuring that matter evolves rather than stagnates. And gravity, though distant in this moment, has shaped the larger structures that brought these atoms together in the first place. Solidity, then, is not a simple property. It is the surface-level experience of a deeply interconnected system, a system that spans from the smallest particles to the largest cosmic structures. And this realization carries a quiet kind of wonder, because it means that every ordinary moment, every time you lean against a surface, every time you feel the weight of your own body, is supported by processes that extend far beyond what you can see. There is also a gentle shift in how emptiness itself is understood. Earlier, it may have seemed like a kind of absence, a lack of substance within atoms. But now, it begins to feel more like a necessary feature, a space within which these forces can operate, within which balance can be achieved. Without that space, without that openness, the interactions that create structure would not unfold in the same way. Emptiness is not a flaw in reality. It is part of the design, part of what allows complexity to emerge. And as you rest with this idea, the original mystery begins to feel less like a contradiction and more like a quiet truth. The world feels solid not because it is filled with matter, but because it is shaped by relationships. It is held together not by substance, but by interaction. And it persists not because it is rigid, but because it is balanced. In the next segment, we will begin to move even deeper, exploring how these forces not only create structure, but also allow transformation, how atoms can change, decay, and evolve over time, revealing that even within stability, there is always motion, always a quiet unfolding of change. As you continue drifting through this quiet exploration, something begins to gently change in the way stability is understood. Up to now, everything has pointed toward balance, toward forces holding matter together, preventing collapse, maintaining structure. But there is another side to this story, one that is just as essential, though often less obvious. Because even while atoms remain stable for long periods of time, they are not truly unchanging. Beneath their apparent stillness, there is always the possibility of transformation, a slow, quiet evolution unfolding over time. At the heart of this lies the nucleus, the dense center of the atom where protons and neutrons are bound together by the strong force. For many atoms, this arrangement is stable, able to persist for billions of years without change. But for others, especially those with larger or more imbalanced nuclei, stability becomes more delicate. The forces inside no longer align perfectly, and the nucleus begins to shift, to adjust, to move toward a more balanced state. This process is what we call radioactivity. Though in this calm context, it can be thought of simply as transformation. This transformation does not happen all at once. It is not a sudden collapse or explosion in most cases. Instead, it unfolds quietly, one atom at a time, each nucleus existing in a state where change is possible but not certain. At any given moment, a particular atom may remain exactly as it is, or it may transition, releasing energy and becoming something slightly different. This uncertainty is not due to a lack of knowledge. It is built into the nature of the system itself. At the quantum level, events are not strictly determined, but probabilistic, meaning that while we can predict overall patterns, we cannot know the exact moment when a single atom will change. And yet, when you look at large collections of atoms, a kind of order emerges from this uncertainty. Even though each individual transformation is unpredictable, the average behavior becomes remarkably precise. We can measure how quickly a group of atoms will transform, how long it will take for half of them to change, and how this process unfolds over time. This balance between unpredictability and regularity is another quiet feature of the universe. A reminder that randomness and order are not opposites, but partners in the unfolding of reality. There is also something deeply connected between this idea of transformation and the forces we explored earlier. The strong force binds the nucleus together, but it does so within limits. When those limits are exceeded, when the balance between attraction and repulsion shifts too far, transformation becomes inevitable. The weak force then plays its role, allowing particles within the nucleus to change identity, turning one type into another, guiding the system toward a more stable configuration. Even electromagnetism contributes, influencing how particles are emitted or how energy is released during these transitions. So once again, we see that nothing in atomic physics exists in isolation. Structure and transformation are not separate processes. They are different expressions of the same underlying rules. Stability allows matter to persist. Transformation allows it to evolve. And together, they create a universe that is both enduring and dynamic. This becomes especially meaningful when you consider how these transformations extend beyond individual atoms. Inside stars, for example, the conditions are such that atoms do not merely remain stable or decay slowly. Instead, they actively combine, merge, and reorganize through processes like fusion. Hydrogen nuclei join together to form helium, releasing energy in the process. Over time, heavier elements are created, building the diversity of matter that eventually becomes planets, oceans, and living systems. In this sense, transformation is not a flaw in atomic structure. It is a creative force. It allows the universe to change, to develop complexity, to move from simplicity toward richness. Without it, matter would remain locked in its earliest forms, unable to give rise to the variety of structures we now observe. Bringing this back to the earlier question of solidity, a deeper layer of understanding begins to emerge. The solid world you experience is not only built from empty space and invisible forces, it is also part of an ongoing process of change. The atoms that form the objects around you are stable enough to maintain structure, but not so rigid that they cannot evolve over time. They carry within them the potential for transformation, even if that transformation unfolds slowly, beyond the scale of everyday perception. There is something quietly humbling in this realization. The floor beneath you, the air around you, your own body, all are composed of atoms that have existed for immense spans of time, yet remain part of a continuous process of change. Some of those atoms were formed in ancient stars. Some may one day become part of entirely different structures. The solidity you feel is just one moment in a much longer story. And as this idea settles in, the sense of reality becomes softer, more fluid, not less real but more expansive. Solidity is still there, still present, still reliable. But now it is understood as part of a larger pattern, one that includes both stability and transformation, both persistence and change. In the final segment of this part, we will begin to bring these ideas together, connecting the forces, the structure, and the transformations into a single, unified picture. And in doing so, we will gently return to the central mystery, allowing it to resolve not as a single answer, but as a quiet understanding that can simply be felt. As we come to the final stretch of this part, everything begins to settle into a single, quiet picture, not as separate ideas, but as layers of the same reality, gently resting on one another. The structure of atoms, the invisible forces that guide them, and the transformations that slowly unfold over time. All of these are not isolated concepts, but expressions of a deeper unity. And within that unity, the original mystery begins to dissolve, not into a simple answer, but into something more complete. You began with the feeling of solidity, something so familiar that it rarely invites questioning. The surface beneath you feels firm, your body feels whole, the world feels stable. But as we've drifted deeper, that certainty has softened, revealing that what feels solid is not built from dense substance, but from space, interaction, and balance. Atoms are mostly empty. Their components rarely touch. And yet, through the interplay of forces, they create structures that resist change, that persist, that feel real. Now, with the addition of transformation, the picture becomes even more complete. Because the world is not only structured, it is also evolving. The same forces that hold atoms together also allow them to change. The same rules that create stability also permit transformation. And this dual nature, this balance between persistence and change, is what allows reality to be both reliable and dynamic at the same time. Without stability, nothing could last. Without transformation, nothing could develop. And so, the universe exists in a state where both are present, quietly intertwined. If you return now to the idea of touching something, resting your hand against a surface, you can begin to feel this more deeply. The resistance you experience is not a rigid barrier, but a response, a momentary balance between forces that rise as atoms approach one another. That balance is maintained continuously, not once, but every instant. It is recreated again and again so smoothly that it feels constant. And yet beneath that constancy, there is motion, electrons shifting, atoms vibrating, energy flowing. Even in stillness, there is movement. Even in solidity, there is change. This realization does not make the world less real. If anything, it makes it more alive. It reveals that what you experience is not a static object, but a process, something that is continuously maintained by the rules of the universe. And those rules, as we have seen, extend far beyond your immediate surroundings. They connect the smallest particles to the largest structures, linking the behavior of electrons to the life cycles of stars. There is also a quiet sense of continuity in this. The atoms that form your body are not new. They have existed long before you, shaped by processes that occurred in distant places and distant times. Some were formed in the early universe, others in the cores of stars, others in violent cosmic events. And now they are here, arranged in a way that allows you to experience, to think, to feel. And just as they came together, they will one day move on, becoming part of other structures, other patterns, other moments in the unfolding story of the universe. In this way, solidity is not just an illusion, but a phase, a temporary arrangement within a much larger process. And yet, it is a meaningful one, because within this arrangement, within this brief moment of balance, something extraordinary happens, awareness emerges. The universe, through the arrangement of atoms in your brain, becomes capable of observing itself. The same rules that govern particles give rise to perception, to thought, to the quiet ability to reflect on existence. This does not require anything beyond the framework we have explored. It is a natural extension of it. Complexity builds upon simplicity. Patterns build upon patterns. And eventually, those patterns become intricate enough to support something like experience. So when you consider the solidity of your body, the firmness of the world around you, it is no longer just a question of physics. It becomes something more reflective, a recognition that everything you feel is part of a much larger system, one that connects you to the universe at every level. And now, as this part comes to a close, the original question can finally rest. Why does something mostly empty feel solid? Because emptiness is not truly empty. It is structured by forces, shaped by rules, and held in balance by interactions that never cease. Solidity is the surface expression of that balance, a stable pattern that emerges from deeper principles. And as you continue into the final part, we will move beyond structure and forces and into something even more expansive, exploring how atoms give rise to life, memory, and technology, and how, in a quiet and profound way, you are not separate from this story, but part of it. For now, if you are still listening, gently comment 2 and let your thoughts settle as the universe continues its quiet work around you. As we move into the final part of this quiet journey, the focus begins to widen, gently expanding beyond atoms themselves and into the patterns they create, the structures they build, and the deeper meaning hidden within their endless interactions. Because while atoms form the foundation of matter, they do not exist in isolation. They combine, rearrange, and organize into increasingly complex systems, and from those systems, something remarkable begins to emerge, something that feels far removed from empty space and invisible forces, yet is entirely built from them. That something is life. If you look at your own body not as a whole but as a collection of atoms, it becomes clear that nothing about it is solid in the traditional sense. Every cell, every molecule, every structure is made from the same atomic framework we have been exploring. Electrons moving in probability clouds, nuclei bound by forces, atoms interacting without ever truly touching. And yet, from this foundation, something organized, responsive, and aware has taken shape. This is one of the quietest mysteries of all. How does something as abstract as atomic interaction give rise to something as immediate as experience? The answer begins with chemistry, the way atoms form bonds and assemble into molecules. When atoms share or exchange electrons, they create stable connections that allow them to build larger structures. These structures can become incredibly complex, forming chains, networks, and patterns that carry information and perform functions. In living systems, certain molecules become capable of storing instructions, guiding processes, and maintaining organization over time. But even here, nothing new is added. There is no extra substance introduced. It is still the same atoms, the same forces, the same rules, simply arranged in more intricate ways. And as these arrangements grow more complex, they begin to exhibit behaviors that are not obvious from the individual components. Molecules interact in sequences, reactions unfold in cycles, and systems begin to regulate themselves. In this way, life can be understood not as something separate from atomic physics, but as a natural extension of it, a higher level of organization emerging from the same foundational rules. Your thoughts, for example, are not separate from this process. They arise from patterns of electrical activity in your brain, which in turn depend on the movement of charged particles, electrons flowing through networks of atoms. Every sensation you experience, every memory you form, every idea that passes quietly through your mind is grounded in these same interactions. You are, in a very real sense, a living expression of atomic physics. And yet, there is something deeply peaceful in recognizing this, because it means that you are not separate from the universe, but continuous with it. The same forces that shape distant stars are present within you. The same atoms that formed in ancient cosmic events now participate in your thoughts and experiences. There is no boundary where the universe ends and you begin. There is only a change in scale, a shift in organization. This continuity extends even further when we consider how atoms move through time. The atoms in your body are not fixed. They are constantly being replaced, exchanged with the environment, recycled through natural processes. The air you breathe, the water you drink, the food you consume, all contribute to this ongoing flow. Over time, the atoms that make up your body today will be part of something else, just as the atoms you now contain were once part of other structures. In this way, you are not a static object, but a process, a temporary arrangement of atoms in motion. And yet, despite this constant change, there is a sense of identity, a continuity of experience. This suggests that what defines you is not the specific atoms themselves, but the pattern they form, the organization, the relationships, the dynamic structure that persists even as the individual components shift. This idea echoes what we have seen throughout this journey. Reality is not built from fixed substance, but from patterns, from relationships that endure even as the underlying components change. And this brings us gently to another layer of understanding. The idea that atoms do not only build structures, but also carry information. The arrangement of atoms in a molecule encodes properties, behaviors, and functions. In living systems, this becomes even more pronounced, with certain molecular structures acting as repositories of information, guiding the development and operation of complex organisms. But even outside of life, atoms carry traces of history. Their composition, their arrangement, their interactions all reflect the processes that formed them. In this sense, atoms can be seen as a kind of memory, not conscious but persistent. They retain the imprint of past events, from the conditions in which they formed to the transformations they have undergone. The iron in your blood, for example, was once created in the core of a star. The oxygen you breathe has traveled through countless cycles, forming and reforming in different contexts. Every atom carries a story, a quiet record of the universe's history. And now those atoms are here, part of you, part of this moment. As we continue, we will gently explore how this connection extends even further into technology, into knowledge, and into the ways humanity has learned to understand and shape the atomic world. But for now, simply rest with this realization that you are not just surrounded by the universe, you are made of it. As this awareness deepens, the story of atoms begins to feel less like something distant or abstract, and more like something intimately connected to every part of your experience, not just in your body, but in the world humanity has quietly built around itself. Because once the behavior of atoms became understood, even in a limited way, it opened a doorway, a way to gently interact with the smallest scales of reality, and through that interaction to reshape the larger world. What is remarkable is that this transformation did not require new materials or hidden substances. Everything humanity has created still relies on the same atoms that have always existed. The difference lies in understanding, in learning how to arrange those atoms, how to guide the movement of electrons, how to work with the invisible rules instead of against them. And from that understanding, entire layers of technology began to emerge, each one rooted in the quiet principles we have been exploring. Consider something as simple as the flow of electricity. It may feel like a continuous current, something smooth and uninterrupted, but at its core, it is the movement of electrons through a structure of atoms. In certain materials, particularly metals, electrons are not tightly bound to individual atoms. Instead, they exist in a kind of shared state, able to move freely across the structure. When a difference in energy is applied, these electrons drift collectively, creating what we experience as an electric current. This movement is not random, but guided by the same forces that shape atomic structure, flowing through pathways defined by the arrangement of atoms themselves. From this simple principle, an entire technological world has unfolded. Wires carry energy across vast distances. Circuits guide the movement of electrons with precision. And at the smallest scales, devices known as transistors control this flow, turning it on and off in patterns that form the basis of computation. Every digital system, every screen, every signal that carries information, all of it depends on the controlled movement of electrons within atomic structures. And yet, even here, nothing has changed at the fundamental level. The same electron clouds, the same forces, the same rules, simply arranged in ways that allow new behaviors to emerge. Light, too, reveals another layer of this connection. When electrons shift between energy states, they emit or absorb photons, tiny packets of electromagnetic energy. By carefully controlling these transitions, it becomes possible to create light that is highly ordered, highly focused. This is the principle behind lasers, where atoms are guided into releasing photons in a synchronized way, producing beams of light that are coherent and precise. These beams can carry information, perform delicate tasks, or measure distances with extraordinary accuracy. Again, this is not something added to nature, but something drawn from it, a refinement of the same processes that occur naturally when atoms interact with light. Even the ability to see inside the human body, to observe structures that would otherwise remain hidden, is rooted in atomic behavior. High-energy photons can pass through matter in ways that depend on atomic composition, revealing differences between tissues. Other techniques rely on the properties of atomic nuclei, their spins aligning and shifting in response to magnetic fields, producing signals that can be translated into detailed images. These technologies extend perception, allowing us to explore layers of reality that were once inaccessible. And then there is time itself, measured not by the movement of large objects, but by the quiet regularity of atomic transitions. Certain atoms shift between energy states with extraordinary precision, repeating their cycles in a way that is almost perfectly consistent. By observing these transitions, it becomes possible to define time with remarkable accuracy, far beyond what any mechanical system could achieve. The steady rhythm of atoms becomes the foundation for navigation, communication, and the coordination of systems across the entire planet. In all of these examples, the pattern remains the same. Humanity has not changed the rules of atomic physics. It has learned to listen to them, to work within them, to gently guide their outcomes. And in doing so, it has extended its reach not by force but by understanding. There is something quietly humbling in this, because it reveals that even the most advanced technologies are not separate from nature, but expressions of it. They are arrangements of atoms shaped by knowledge, patterns built upon patterns, layers of interaction extending from the smallest scales to the largest systems. And yet, alongside this ability comes a responsibility. The same understanding that allows for creation also allows for destruction. The energy stored within atomic structures, particularly within the nucleus, can be released in ways that are both powerful and difficult to control. This dual nature is not a flaw in the system, but a reflection of its completeness. The forces that build can also transform. the rules that create stability can also enable change. So once again, the theme returns balance, not only within atoms, but within how they are understood and used. As you rest with this idea, the boundary between natural and artificial begins to soften. The devices around you, the systems you rely on, the technologies that shape modern life, all are part of the same continuum. They are not separate from the atomic world, but extensions of it, expressions of how understanding can shape reality without ever leaving its fundamental framework. And as we move toward the final segments of this journey, we will gently return to a more reflective space, exploring how all of this, the forces, the structures, the transformations, and the technologies, come together into a single, quiet perspective, one that connects you not just to the world around you, but to the deeper fabric of existence itself. As this journey continues to unfold, the boundaries between the physical and the philosophical begin to soften even further, not because the science becomes less precise, but because its implications become more expansive. What began as an exploration of atoms, of empty space and invisible forces, now begins to reveal something quieter, something almost reflective. A realization that the nature of reality is not just something to understand, but something to experience differently. Because if everything you see, touch, and feel is built from patterns rather than substance, if solidity is an emergent effect rather than a fundamental property, then the world is not quite what it appears to be. Not in a deceptive sense, but in a deeper, more layered way. What you perceive is real, but it is a translation, an interpretation shaped by your senses, built upon interactions that occur far beyond direct awareness. Take a moment to consider this gently. When you look at an object, you are not seeing the object itself in any absolute sense. You are seeing light of photons interacting with the atoms on its surface, reflecting into your eyes, triggering signals that your brain assembles into an image. That image feels immediate, solid, and complete. But beneath it lies a chain of interactions, each one governed by the same atomic rules we have been exploring. When you feel warmth, it is not a substance entering your body, but energy, the motion of atoms transferring through interactions. When you hear sound, it is not a thing moving through space, but vibrations, patterns of motion passing through atoms and into your senses. Every experience is rooted in these interactions, translated into forms that feel intuitive, even though their origins are anything but. And this is where a quiet shift begins. Reality, as you experience it, is not just the external world. It is the relationship between that world and your perception of it. The atoms and forces create the structure, but your senses create the experience. And together they form the reality you know. This does not make reality less real. It makes it more complete, because it reveals that what you experience is not separate from the underlying structure, but a natural extension of it. The same rules that shape atoms also shape perception, allowing the universe to become aware of itself through patterns like the one you are part of. And within this perspective, another layer begins to emerge, one that connects back to something we touched on earlier, the idea of memory. Atoms, in their quiet persistence, carry traces of history. Their arrangements reflect past interactions, Their compositions reveal the conditions under which they formed. In this sense, matter is not just structure but record. The universe, through atoms, retains a kind of memory, not conscious, but encoded in patterns that endure across time. When scientists study distant stars, they read the signatures of atoms, identifying elements through the light they emit or absorb. These patterns reveal temperatures, motions, compositions, stories written not in words, but in the behavior of electrons. The same is true on Earth. The arrangement of atoms in a rock can reveal its age, its origins, the conditions it has experienced. Even within your own body, atoms carry this quiet continuity. They have existed long before you, and they will continue long after. And yet, for a brief moment, they are arranged in a way that allows awareness to emerge, to reflect, to ask questions about existence itself. There is something deeply calming in this idea, because it suggests that nothing is truly isolated. Everything is part of a continuous flow, a movement of atoms through time, forming patterns that persist for a while, then change, then reform in new ways. You are not separate from this flow. You are one of its expressions. And just as atoms carry memory, they also carry potential. The same structures that form rocks and stars can, under the right conditions, form life, thought, and technology. The difference is not in the atoms themselves, but in how they are arranged, how they interact, how the patterns evolve. This brings us back, in a quiet way, to the central theme of this entire journey. Reality is not built from things. It is built from relationships. Atoms are not solid objects, but systems of interaction. Forces are not visible threads, but influences shaping behavior. And everything you experience is the result of these relationships unfolding in consistent, balanced ways. Even the distinction between emptiness and substance begins to blur. What seemed like empty space is now understood as a region where interactions can occur, where forces can act, where possibilities exist. Emptiness is not nothingness. It is the space within which structure becomes possible. And as this idea settles in, the world may begin to feel slightly different, not less stable, but more open, more fluid, more connected. The surface beneath you is still there. Your body is still here. The room around you remains unchanged. But now, beneath that familiarity, there is a quiet awareness of what lies underneath. A deeper layer of understanding that does not replace your experience, but gently enriches it. And as we move toward the final segments, we will allow this awareness to soften even further, transitioning from explanation into reflection, from understanding into a calm sense of connection with the universe as a whole. As everything we've explored begins to settle, the pace of this journey naturally slows. Not because there is nothing left to discover, but because what remains is less about explanation and more about quiet reflection. You have moved from the smallest scales of existence, through atoms and forces, through transformation and structure, and now what remains is simply to see how it all rests together gently without effort. The world around you has not changed. The surface beneath you still feels steady. The air still surrounds you softly. Your body still carries the same sense of presence. But beneath that familiarity, there is now a deeper awareness that everything you experience is not made of solid substance, but of patterns, of relationships, of balance held across empty space. And there is something surprisingly calming about that, because it means the universe is not rigid. It is not fixed in a way that resists understanding. Instead, it is open, structured, but not solid in the way it appears. Everything is held together not by density, but by interaction. Not by mass alone, but by the quiet cooperation of forces that never stop working, never fall out of rhythm. Even now, as you rest, those forces are still at work. The atoms in your body are gently vibrating, their electrons shifting within their probability clouds. The surface beneath you is responding in the same way, its atoms maintaining a balance that supports your weight. There is no stillness at the atomic level, only constant motion, constant adjustment, constant balance. And yet, from this endless motion comes stillness. From this quiet activity comes the feeling of rest. This is one of the most subtle truths you've encountered. Stillness is not the absence of motion. It is the harmony of motion. When everything moves in balance, when forces align and interactions settle into stable patterns, the result is something that feels calm, stable, and continuous. The world does not need to stop moving to feel still. It only needs to move in a way that remains consistent. And this consistency extends far beyond your immediate surroundings. The same atomic rules that shape your body are shaping distant stars, distant galaxies, regions of space so far away that their light takes millions or billions of years to reach you. And yet, when that light arrives, it behaves in the same way, interacting with atoms, following the same principles, revealing that the universe is unified in a way that is both simple and profound. There are not different rules for different places. There is one framework expressed everywhere. And within that framework, everything that exists, from the smallest particle to the largest structure, participates in the same quiet balance. You are part of that balance, not separate from it, not observing it from the outside, but fully within it. The atoms in your body are not different from the atoms in distant stars. They follow the same rules, respond to the same forces, participate in the same interactions. The difference is only in arrangement, in pattern, in the way those atoms have come together in this moment to form something capable of awareness. And that awareness, your awareness, is simply another expression of the same underlying reality. There is no need to make it more complicated than that. No need to separate mind from matter or experience from structure. Everything you are, everything you feel, everything you perceive is part of the same continuous system. And as this realization settles in, something begins to soften. The boundary between you and the world becomes less rigid, not disappearing, but becoming more fluid, more connected. You are still here, still yourself, but now, gently, you can sense that your existence is part of something much larger, something that does not end at the edges of your body, but continues outward through the air, through the planet, through the stars, all the way into the vast quiet of space. And in that vastness, the same rules apply. The same balance holds. The same patterns repeat. There is a quiet comfort in this continuity. A sense that nothing is isolated and nothing is disconnected. Everything belongs to the same unfolding process. And as your thoughts begin to slow, as your attention softens, you can simply rest in that idea. No need to analyze it further. No need to hold on to every detail. Just allow the understanding to be there, gently in the background. A quiet awareness that the world is not solid, but beautifully structured. That emptiness is not absence, but possibility. That stability is not rigidity, but balance. And that you are part of that balance. In the final segment, we will let this understanding settle completely, allowing the journey to fade into a calm, drifting reflection where the details become softer and only the feeling remains. And now, as this journey gently comes to rest, there is nothing more you need to follow, nothing more you need to understand, only something quiet to feel. Because everything you have explored, from the smallest atoms to the largest structures in the universe, has been leading here, not to a conclusion, but to a kind of stillness, a place where understanding softens into awareness. The world around you remains exactly as it was. The surface beneath you still feels steady. The air still rests softly against your skin. Your body still carries the same quiet presence it always has. And yet, beneath that familiarity, there is now a deeper layer, a gentle knowing that everything you feel, everything you experience, is not built from solid substance, but from patterns, from relationships, from balance unfolding across space. There is no need to picture atoms now. No need to imagine electrons or forces. They are still there, still quietly shaping everything. But you can let those details fade, like distant stars becoming softer as your eyes begin to close. What remains is simpler, a sense that the world is not rigid, but gently held together. A sense that stability is not something fixed, but something continuously maintained. A sense that everything around you and everything within you exists in a kind of quiet agreement, a balance that never needs to announce itself because it never breaks. And as you rest here, you may begin to notice something else, that the same balance exists within you, your breath moving slowly, in and out, not forced, not controlled, just happening. Your body supported without effort, held in place not by tension, but by the same invisible interactions that shape the world around you. Your thoughts beginning to drift, becoming softer, less defined, like patterns that no longer need to hold their shape. There is nothing you need to hold on to, because everything at its deepest level is already held. The atoms in your body quietly arranged, the forces between them gently balanced, the patterns of your mind slowly settling. Even time itself measured not in moments, but in the steady rhythm of change, unfolding without urgency. And somewhere within this, there is a quiet realization that nothing is truly separate. The air you breathe, the surface you rest upon, the distant stars, and your own awareness are all part of the same continuous process. Different patterns, different scales, but the same underlying reality. You are not outside of it. You are not observing it from a distance. You are within it, made of it, part of its unfolding. And there is something deeply peaceful in that, because it means there is no need to resist, no need to hold things together, no need to make reality feel solid or stable or certain. It already is, in the only way it ever needed to be, gently balanced, quietly consistent, endlessly unfolding. And as this understanding becomes softer, less like an idea, and more like a feeling, you can simply let yourself drift. Let the details fade. Let the questions dissolve. Let the structure of everything you've explored settle into the background, like a quiet hum, no longer something to follow, but something that supports you without effort. The universe continues, whether you think about it or not. Atoms continue to move. Forces continue to balance. Patterns continue to form and dissolve. And you, for this moment, can simply rest within it. No effort, no tension, just presence, just stillness, just the quiet sense of being part of something vast and calm and endlessly steady. And as you drift further, you might notice that the need to understand becomes lighter, the need to focus becomes softer, and what remains is something simple, a quiet awareness, floating gently, supported by a universe that never stops holding itself together, and holding you within it. If you're still here, still listening, let me know softly by commenting 3, not as a task, but as a small signal that you've drifted all the way to the end of this quiet journey. And now, you can simply rest,